Everything moves. Every atom, every star, every galaxy. All of it caught in an endless dance of invisible power. Space itself stretches and bends. Time flows and folds. Light surrenders to gravity's pull, and matter tears itself apart in nuclear fire. The universe is not still. It never was. Something is driving it. A force older than creation, silent, yet everywhere. But what is it? What is the most powerful force in existence? Physicists name four fundamental ones: gravity, electromagnetism, the strong and weak nuclear interactions. Yet none seem to tell the whole story. Gravity can sculpt galaxies but cannot hold an atom together. The strong force binds matter, but vanishes beyond the smallest scales. Each reigns in its own domain, ruling a fragment of reality. But behind them all, something deeper may weave the pattern. Something that compels energy to move, time to unfold, and awareness to awaken. What if the greatest force isn't written in equations, but in existence itself? The same pulse that spins galaxies may beat within your mind. Every question, every breath, every act of wonder, all part of the same unfolding power. The cosmos moves, because something within it still dares to ask why. There are only four forces holding all of reality together, and yet there's still not enough to explain it. Four invisible threads, stretching from the birth of the cosmos to every motion of your hand. Without them, stars would never ignite, atoms would never bind, and thought itself would never rise from the dust. They are the oldest laws in existence, not written by gods or minds, but by the universe itself as it learned to exist. In the beginning, there were no forces at all. The newborn cosmos was unified, a single, incomprehensible field of pure energy. Time had just begun to tick, space had barely learned to stretch, and the temperature soared beyond comprehension. Then, in less than a trillionth of a second, unity shattered. The first great symmetry broke. Out of that rupture came gravity, the first architect of form. Gravity does not push or pull in the way we imagine. It bends the stage itself. It tells space how to curve and matter how to move. In that first instant, when energy condensed into particles, gravity began to whisper its silent influence, gathering what had once been chaos into shape. Every star, every planet, every spiral of galaxies owes its very coherence to this gentle sculptor of the void. It is the weakest of all forces by strength, yet the most dominant by reach. One grain of dust barely feels it, but a billion trillion stars cannot escape it. It binds the infinite. It is patience incarnate. And yet, for all its grandeur, gravity is a mystery even to those who study it most. No particle has ever been found that carries its power. Physicists call the hypothetical messenger the graviton, but it remains unseen, a ghost in the equations. Why is gravity so weak compared to the others? If you lift a magnet, it can overcome the pull of the entire planet beneath your feet. That imbalance, the hierarchy problem, haunts modern physics. Why should the universe's grandest force be its most fragile? Perhaps gravity's true strength is not in its force, but in its persistence. Over cosmic time, it wins by never giving up. It shapes the very structure of space itself. It draws gas into stars, stars into galaxies, galaxies into clusters, and clusters into the vast web we now observe through telescopes reaching billions of light years. The universe is a tapestry woven from gravity's patient hand, the silent artisan of form. Then came light. Out of the cooling fire of creation, another force awakened: electromagnetism. If gravity sculpts the universe's bones, electromagnetism fills them with life. It is the reason atoms hold together, the cause of color, chemistry, and communication. It is why the sky glows, why stars burn, why your thoughts crackle across neurons. Every photon that ever existed carries its message. Electromagnetism emerged in the first microseconds after the Big Bang, when the universe cooled just enough for energy to diversify. Photons, quanta of light, began to move freely, no longer trapped by the plasma sea. They became the messengers of space, weaving through matter, binding particles into order. When positive and negative charges find each other, they dance to this force's rhythm. The electromagnetic field is the pulse of interaction, the dialogue between all charged things. For billions of years, electromagnetism has been the storyteller of the cosmos. Every starlight that reaches your eyes began as a photon born from fusion, traveling across unthinkable distances without ever tiring. Light never slows, never ages. It is both timeless and fleeting. And in its behavior, the universe reveals its precision. When electrons move, they generate fields. When fields oscillate, they create waves. Those waves become the spectrum of reality. From the invisible whispers of radio to the burning roar of gamma rays, all the beauty of color, all the warmth of a star, all the spark of thought, born from the electromagnetic symphony. If gravity is the sculptor and electromagnetism the artist, then the nuclear forces are the blacksmiths, unseen, ferocious, and foundational. They are the reason matter exists at all. The strong nuclear force, the mightiest of the four, holds the cores of atoms together. Without it, protons, each positively charged, would repel and fly apart, scattering the universe into a useless mist. But deep within atomic nuclei, the strong force binds them tighter than imagination allows. This force was born when the universe was less than a millionth of a second old, at temperatures 1 trillion times hotter than the sun. As the cosmic fire cooled, quarks, the smallest building blocks of matter, found themselves bound into protons and neutrons by the strong interaction. It's a force so fierce that separating two quarks takes more energy than creating two new ones. The universe protects its secrets with unimaginable intensity. Physicists describe this through color charge, a concept far removed from ordinary vision. Quarks come in shades of red, green, and blue, not visible colors, but mathematical ones, and the strong force demands they always combine into neutral harmony. It is a cosmic rule of balance, ensuring that no fragment of matter can exist alone. In this way, the strong force mirrors something deeper: the idea that isolation is forbidden, that existence itself is relational. But not all nuclear power is creation. Some is decay, and that is where the weak nuclear force enters the story. Subtle, elusive, yet responsible for transformation. While the strong force binds, the weak force changes. It allows particles to become something new, turning neutrons into protons, releasing neutrinos that pass through you by the trillions every second. Without the weak interaction, stars would never shine. Their fusion depends on this delicate process, converting hydrogen into helium, releasing energy that becomes starlight. The weak force also dictates the end of things. It governs radioactive decay, the slow unraveling of unstable matter, the quiet countdown of existence. What seems destructive is, in truth, creative, the engine of change that fuels the evolution of the cosmos. Through decay, the universe keeps moving forward, each dying particle seeding new beginnings. In the first seconds after the Big Bang, these four forces were not separate at all. They were one, a single unified interaction. As the universe expanded and cooled, symmetry broke in stages. The strong force split first. Then the electromagnetic and weak forces divided, leaving gravity as the oldest relic of unity. Physicists call this symmetry breaking, but poetically, it is the universe learning to differentiate, to create diversity from oneness. Even now, scientists search for a grand unified theory, a single framework that reweaves these four into one coherent whole. Quantum field theory hints that electromagnetism and the weak force already share a hidden ancestry. The electro-weak force, proven in the 20th century through colossal experiments that made the invisible visible. Perhaps, deep enough beneath reality's surface, all four are simply faces of a single truth. And yet, for all our equations, something doesn't fit. Gravity refuses to cooperate with the quantum rules that govern the others. It remains the outsider, the philosopher of the forces, vast, continuous, and smooth, while the others flicker in discrete packets of energy. When physicists try to merge gravity with quantum mechanics, the math collapses into infinity, as though nature itself resists being fully known. This dissonance may not be a failure of our theories, but a clue that reality itself is built on paradox. The weakest force commands the largest scales. The strongest hides within the smallest. The visible depends on the invisible. Every level of existence depends on what it cannot see. Consider this. If you stood in the first second after the Big Bang, you wouldn't see fire or explosions, but a featureless glow. Only as the universe expanded did distinctions emerge. Light from darkness, matter from energy, forces from unity. Those ancient powers still act in every instant. When you drop a stone, gravity answers. When you switch on a light, electromagnetism awakens. When a star is born, the nuclear forces sing their duet of binding and decay. You are surrounded by the echoes of the universe's first moments. But the greatest mystery is not that there are four forces. It's that there are only four. Why not 3 or 5 or infinite? Why this particular balance that allows atoms to exist, stars to form, and life to rise? If gravity were slightly stronger, the universe would have collapsed long ago. If electromagnetism were weaker, atoms would drift apart, unable to form molecules. The cosmic recipe seems impossibly precise, as though tuned for creation. Some call it coincidence. Others call it design. Perhaps it is neither, but necessity. The universe may be the only way it could be, a self-consistent system that gives rise to its own observers. But that idea, too, leads deeper, for if consciousness arises from these forces, might it also influence them? We are told the four forces explain everything, and yet they do not explain why there is anything to begin with. They describe the rules, but not the reason. They show how matter moves, but not why it awakens. Somewhere beyond these equations, another kind of power may be hiding. One that connects the material and the immaterial, the physical and the aware. But that is for later. For now, we stand with the ancients, Four pillars of reality, invisible yet eternal. Gravity sculpts the vastness. Electromagnetism breathes fire into it. The strong force binds its essence, and the weak force teaches it to change. Together, they weave the cosmic web, holding the universe in delicate balance. And still, something is missing. The forces we know explain the machinery, but not the motive. The equations balance, but the story feels incomplete. Why does the universe seem to strive, to evolve, to awaken? Perhaps the most powerful force is not among the four at all. Perhaps it is the one that set them in motion, the one that compels existence to exist. The search for that answer begins, where physics ends and wonder begins. How can something weaker than a paperclip's hold entire galaxies captive? It is a paradox so vast that even the stars obey it. Gravity, the quiet dictator of the cosmos, is the gentlest of all the forces, yet the most commanding. Its touch is almost imperceptible between small things, but across light years, it sculpts the architecture of eternity. It is not strength that grants it dominion, but patience. To understand gravity is to follow the story of everything that has ever held together. From the swirl of galaxies to the fall of an apple, gravity is the rhythm that gives the universe form. But unlike the other forces, it doesn't push or pull through space. It creates space. Einstein's great revelation in 1915 transformed our understanding. Gravity isn't a force at all, but the curvature of space-time itself. Imagine a vast, invisible fabric stretching in every direction, a cosmic web woven from time and dimension. Place anything with mass upon it, and the fabric bends. The heavier the mass, the deeper the curve. And everything nearby, whether a planet, photon, or particle of dust, moves along that curvature. Not because it's pulled, but because the shape of reality itself has changed. This is why the Earth orbits the Sun, and why light itself, though weightless, bows before the presence of stars. Gravity doesn't command through might. It persuades through geometry. It's the universe speaking its first mathematical language, a dialogue between mass and motion. In this language, time slows where space bends deeply. Stand at the edge of a black hole, and seconds for you become centuries for the rest of the cosmos. The greater the gravity, the slower the tick of existence. In that sense, gravity isn't just the sculptor of space. It's the editor of time. But to understand how such a subtle curvature can rule the cosmos, we must return to the beginning. In the first moments after the Big Bang, gravity was born alongside everything else. Yet it was already the most patient of all. The strong nuclear force built atoms. Electromagnetism lit the stars. But gravity had no need to rush. It waited quietly as the universe expanded and cooled. Then, over hundreds of millions of years, it began to gather what the others had made. Tiny ripples of density, fluctuations in the early cosmic plasma, grew under gravity's careful hand. Those ripples became clouds, clouds became stars, and stars became galaxies. It is the slowest craftsman imaginable, but the most enduring. Its work is never undone. Every galaxy in the night sky is a monument to its persistence. Every black hole is its signature, the final seal of its artistry. Gravity does not fight chaos. It uses chaos. The collapse of matter is its instrument, the birth of structure its song. Yet, for all its grandness, gravity remains absurdly weak. The magnetic field of a small refrigerator magnet can overcome the entire gravitational pull of Earth. If you were to compare the strength of gravity to the electromagnetic force between two protons, gravity would be 1038 times weaker, a number so vast that it defies comprehension. If gravity were slightly weaker still, stars could never ignite. If it were stronger, everything would collapse into black holes. Its delicacy is not a flaw. It is the reason we exist. This weakness is one of physics' deepest mysteries. Why should the fabric of space-time itself interact so feebly with matter? The question haunts every attempt to unify gravity with quantum mechanics. The other three forces fit neatly into the quantum framework, described by particles, exchanged like notes in a cosmic orchestra. But gravity resists this treatment. It is continuous, smooth, unquantized. It behaves like the mind of the universe, unseen, indivisible, and infinitely patient. Theorists have tried to imagine a quantum of gravity, a particle called the graviton, that would carry its influence the way photons carry light. But no experiment has ever found one. The energies required to detect it would exceed the power of the universe's largest machines. It's as if gravity hides its quantum face behind a veil of scale, refusing to reveal how the very large and the very small are truly one. Some suspect the secret lies in extra dimensions. In string theory, gravity may not be weak at all. It may simply be leaking. The idea suggests that our universe, a four-dimensional brain, floats within a higher dimensional space. The other forces are confined to our brain, but gravity seeps through the cracks, spreading its influence thinly across unseen dimensions. We feel only its faint echo, a shadow of a deeper reality. Whether or not that's true, gravity's paradox endures. How can the weakest force define the fate of everything? The answer may lie in its infinite reach. The nuclear forces are confined within atoms. Electromagnetism cancels out as positive and negative charges balance across vast scales. Only gravity always adds. Every particle contributes, no matter how small. There is no negative mass, no countercharge to neutralize it. Over time, its influence compounds until even the faintest pull becomes destiny. This is why gravity rules the stars. Within clouds of hydrogen gas, it draws atoms together, increasing pressure and temperature until fusion ignites. Light is born from gravity's collapse. Stars are its children. Yet gravity is also their executioner. When a star exhausts its fuel, the balance between radiation pressure and gravity breaks. The same force that gave it life begins to crush it. Some stars end as white dwarfs, others as neutron stars, cities of matter compressed into spheres no wider than a few kilometers. But for the most massive, there is no end but surrender. Gravity wins absolutely. When collapse becomes unstoppable, even light cannot escape. Space folds inward, time halts, and a singularity forms, a point of infinite density where the laws of physics dissolve. This is a black hole, gravity's ultimate expression. To an outside observer, it appears as an event horizon, a one-way boundary in space-time. Anything that crosses it vanishes not just from view, but from meaning. Einstein's equations predict the singularity, but they cannot describe it. Inside, time and space trade places. The future itself points inward, toward the center. Once inside, movement isn't a choice. It's a trajectory through destiny. And yet, to the universe beyond, black holes are not dead ends. They are engines. When matter falls in, it releases energy. sometimes more than 1,000 suns combined. Quasars, the brightest beacons in the cosmos, are powered by gravity's fury. Out of destruction, creation blazes anew. There is a haunting symmetry here. Gravity both binds and breaks. It is creation's sculptor and annihilation's hand. Wherever it builds, it also erodes. Galaxies form and merge, but gravity ensures they will one day fall silent. Even light itself bends toward its will. This duality, the tender and the terrible, is what makes gravity so humanly resonant. It mirrors the paradox of life itself, that endurance and surrender, creation and destruction are never truly separate. And yet, for all our equations, gravity still hides its soul. Einstein's vision describes how it behaves, not what it is. Is space-time a substance, a field, a relation between events? No one truly knows. Every attempt to probe its essence ends in paradox. Some physicists now suspect that gravity might not be fundamental at all, that it could emerge from something deeper, like temperature arises from the motion of atoms. In this view, space-time itself is an illusion, a large-scale approximation of countless microscopic interactions. If this is true, then gravity may be the universe's memory, the sum of all information encoded in matter and energy. When a star collapses into a black hole, its physical form disappears, but the information it carried remains, perhaps imprinted on the horizon itself, like a cosmic archive. This leads to one of the most profound paradoxes in modern science, the information problem. If information is never lost, then what happens to it when the black hole evaporates? Does the universe remember, or does it forget? Stephen Hawking's equations showed that black holes emit radiation, a faint glow born of quantum effects near the event horizon. Over unimaginable timescales, this radiation causes the black hole to shrink, fade, and finally vanish. But if it disappears completely, where does the information go? Quantum theory insists it must be preserved. General relativity suggests it's gone forever. Between those two truths lies the greatest unsolved conflict in physics, the chasm between the continuous and the discrete, between the infinite and the finite. The deeper we go into gravity, the less we understand what it is. It governs the motion of galaxies and the flow of time, yet slips through our grasp like a dream. It cannot be shielded, switched off, or defied. You cannot escape it, only fall more slowly. And still, it never stops pulling, never stops shaping. It is the universe's patience made visible. Perhaps that is why gravity feels less like a force and more like a conversation between being and becoming. Everything that exists responds to it, not because it must, but because it is. A stone falls because space tells it how to move. Space curves because the stone tells it where to be. This reciprocity is the essence of relationship, not command, but cooperation, and within that idea lies a strange reflection of consciousness itself. The mind, too, bends to what it observes. The act of awareness changes the pattern of perception, just as mass changes the shape of space-time. The more we look, the deeper the well becomes. Perhaps gravity is not only the structure of the universe, but the metaphor of existence, showing us that connection is power, and persistence outlasts strength, because what gravity truly teaches is endurance. Stars burn out, galaxies collide, civilizations rise and fall. But gravity remains. It waits, eternally patient, for the next dance. In the far future, when the last star flickers out, and only black holes remain, gravity will still whisper across the void. And when even they evaporate, the faint ripple of their memory, gravitational waves, will continue to ripple through the fabric of nothingness, carrying the story of all that ever was. Maybe that is its ultimate meaning. Not domination, but devotion. Not strength, but time. Gravity does not conquer the universe. It remembers it. Every orbit, every collapse, every curve of light, all are notes in its endless requiem. And so the weakest of all forces turns out to be the most inevitable. The universe bows to it not because it must, but because it cannot forget. Gravity binds, breaks, and endures. The timeless heartbeat of existence itself. Every breath you take began inside an explosion billions of times brighter than the sun. The oxygen in your lungs, the iron in your blood, the calcium in your bones, all of it was forged in fire, born from the dying throes of ancient stars. Long before life took its first breath, the cosmos had already exhaled, and within that breath lay the chemistry of everything. Stars are not eternal. They are burning questions, self-consuming furnaces that take the simplest element, hydrogen, and through unimaginable pressure, transform it into something new. Inside their blazing cores, the nuclear and electromagnetic forces perform an ancient dance, one that began when the universe was still a child. These are the raw engines of creation, the two forces that turn chaos into order, fire into form, and energy into matter that can one day dream. If gravity is the sculptor, then the nuclear and electromagnetic forces are the heart. Their interplay defines the rhythm of every living atom. Deep inside the sun, gravity crushes hydrogen atoms together with such intensity that they overcome their natural repulsion. That invisible electromagnetic barrier that keeps positive charges apart. And when they do, the strong nuclear force takes over, binding them into helium, releasing a burst of energy that travels outward as light. That light crosses the void for 8 minutes before it touches your skin, warming your face with the memory of fusion. This process, the merging of small nuclei into larger ones, is the alchemy of the universe. Fusion converts mass into energy through Einstein's most famous equation, E(r)mc2. A tiny fraction of matter, when transformed, releases enough energy to power worlds. Every second, the sun converts 4 million tons of matter into pure light. Yet it is so vast, so patient, that it will continue to burn for billions of years more, turning its own body into brilliance. The sun's fire is not flame. It is a quantum storm. Inside, the density is so extreme that individual atoms lose meaning. Protons and electrons swim in a plasma sea. Temperatures soar to 15 million degrees, and the nuclei of hydrogen smash together fast enough to fuse despite their repulsion. It's a delicate balance. Too little pressure, and fusion ceases. Too much, and the star detonates. The universe thrives in this narrow band between collapse and explosion, between too much and too little, the eternal middle way. And yet, even this balance is temporary. When hydrogen runs low, gravity tightens its grip again. The star contracts, grows hotter, and begins to fuse helium into carbon, oxygen, and heavier elements. In the largest stars, this chain continues. Silicon, magnesium, sulfur, iron. Each new step releases less energy than the one before, until the process reaches iron, the cosmic dead end. Fusing iron consumes more energy than it gives. For a star, that is the end of creation and the beginning of destruction. When a massive star reaches this limit, it can no longer resist its own weight. Gravity crushes the core inward, while the outer layers rebound outward in a cataclysmic explosion, a supernova. In that brief, blinding instant, the universe performs its greatest act of creation through destruction. The temperatures rise to billions of degrees, and for a few seconds, fusion resumes with reckless abandon, forging elements heavier than iron. Gold, silver, uranium, everything rare and precious. Then the star tears itself apart, scattering its ashes across the cosmos. Those ashes become planets, oceans, and hearts. Every atom heavier than hydrogen and helium was made this way. The calcium in your bones was forged in the death of a star. The iron in your blood once flowed through a stellar core. When you breathe, you are inhaling the remnants of ancient supernovae. You are literally stardust recycled and reassembled. This is not metaphor, it is chemistry. The electromagnetic forces that hold your molecules together today are the same that bound the plasma in those stellar furnaces eons ago. But the story doesn't end with destruction. Out of the debris of those detonations, gravity begins again, pulling scattered atoms into new clouds, new stars, new worlds. Every explosion becomes a seed. The galaxies are gardens of fire and renewal, each generation of stars building upon the ashes of the last. The nuclear cycle is not a tragedy. It's a heartbeat. Creation, collapse, creation again. The rhythm of eternity. Inside the smallest particles, this process continues endlessly. The strong nuclear force, 100 times stronger than electromagnetism, holds the nuclei of atoms together. Without it, every proton's positive charge would drive the atom apart. The electromagnetic force governs how atoms interact, but the strong force keeps them from disintegrating. And both are inseparable in the cosmic dance of energy and structure. In the atom's heart, protons and neutrons exchange particles called gluons, the carriers of the strong force. The name is almost poetic. Gluons glue matter together, ensuring that quarks, the fundamental constituents of protons and neutrons, never exist alone. This confinement is absolute. To tear a quark free would require infinite energy, enough to create 2 new quarks in the process. Matter itself refuses to be lonely. At larger scales, electromagnetism takes command. It is the architect of chemistry, dictating how atoms link into molecules, how molecules shape into proteins, and how those proteins eventually awaken into consciousness. Every chemical bond, every flicker of lightning, every spark of thought, all are born from the electromagnetic dialogue of charged particles. The same field that paints the sky with auroras also sculpts the architecture of the mind. The electromagnetic force is also what allows starlight to reach us. When fusion releases photons inside a star, they bounce around for thousands of years before escaping into space. Once free, they travel unimpeded, never aging, never slowing. Some of the light that touches your eyes tonight began its journey before humanity existed. Every photon is a messenger from the past, carrying within it the memory of a universe that never stops creating. In the heart of a supernova, these photons become fury. When the core collapses, the outer layers rebound, generating a shock wave that propagates through space faster than comprehension. For a few moments, the energy output exceeds that of an entire galaxy. Neutrinos, ghostly particles born from the weak force, stream outward in torrents, passing through everything without pause. 1 teaspoon of the matter left behind, now compressed into a neutron star, would weigh 1 billion tons. Matter, stripped of space itself, reduced to its ultimate density. These remnants are not corpses. They are archives. Every neutron star, every supernova remnant, every black hole holds the story of transformation, the record of the universe learning how to turn fire into form. The violence of the stars is not chaos. It is art. Destruction becomes creation. Entropy becomes evolution. And within this alchemy lies a reflection of ourselves. The same forces that bind nuclei also bind memories. The same balance that keeps atoms stable also governs emotion. Too much repulsion, and things fall apart. Too much attraction, and they collapse. Nature seems to prefer tension, not peace. Creation thrives on conflict. In this sense, the nuclear and electromagnetic forces are not just physical. They are existential. They show us that beauty emerges not from stillness, but from struggle. Stars are born from pressure. Elements emerge from collapse. Life itself requires both. The DNA that carries your existence is held together by the same electromagnetic attraction that drives lightning across the sky. Every heartbeat is a tiny echo of fusion. Electrical impulses dancing through the darkness, turning chemistry into experience. We often imagine the universe as a cold, indifferent place, but its very foundation says otherwise. The cosmos burns with the desire to create, to take raw energy and turn it into complexity. The balance between nuclear ferocity and electromagnetic harmony mirrors the duality within every living thing, the urge to consume and the urge to connect. The universe doesn't merely exist. It expresses. There is also humility in this knowledge. The fire that sustains us is temporary. The sun itself will one day exhaust its fuel, swelling into a red giant, swallowing the inner planets, then collapsing into a white dwarf, a dense ember cooling in silence. Yet even in death, it will continue to radiate for trillions of years, giving back to the void what it once borrowed. Every end feeds another beginning. When you look up at the night sky, you're seeing billions of furnaces, each in a different stage of life. Some are just igniting, others are nearing collapse. A few have already exploded, their light still crossing the gulf of time to reach you. In their glow lies the most sacred truth of existence, that everything is connected through energy transformed. Perhaps that is why humans are drawn to fire. Our ancestors gathered around it for warmth and story, sensing instinctively what their minds could not yet articulate, that the flame before them was kin to the stars above. In that orange glow flickered the same process that drives the cosmos, the conversion of matter into meaning. The electromagnetic and nuclear forces do not simply govern physics, they govern destiny. They are the universe's way of saying that nothing truly dies. It only changes form. Every death is the beginning of new chemistry. Every collapse becomes the seed of creation. Even the blackest void is never truly empty. It hums with potential energy, waiting for the right spark. So, the next time you feel the warmth of sunlight or watch lightning split the sky, remember what you are touching. Not light, but legacy. You are feeling the heartbeat of a cosmos that never stopped burning. The universe is not powered by chaos. It is powered by the relentless desire of matter to become something more. And if that desire could speak, it might say, "I was once a star," because, in the truest sense, you were. Every thought, every breath, every heartbeat, the universe remembering its own fire. What if the most powerful force in existence is something we've never even detected? We see galaxies swirling in the dark, stars orbiting their centers at impossible speeds, and space itself expanding faster than light can chase it. Yet everything we can observe, every atom, photon, and planet, accounts for less than 5% of all that exists. The rest is invisible, untouchable, unknowable. The universe we think we see is only the surface of a vast hidden ocean. Beneath it, unseen forces sculpt reality, not by pushing or pulling, but by changing the fabric of existence itself. For centuries, humanity believed it had uncovered the map of the cosmos. Newton revealed the machinery of motion. Einstein showed us space-time's curvature. Quantum theory explained the strange dance of the small. But as telescopes grew more powerful, as our eyes reached deeper into the past, the universe began to defy its own equations. Galaxies spun too quickly. Their outer stars moved as if held by invisible hands. The math was merciless. There wasn't enough matter to keep them from flying apart. Something unseen was binding them together, something heavier than all the stars combined. That unseen substance is what we now call dark matter. Dark, not because it is sinister, but because it neither emits nor reflects light. It is transparent to radiation, invisible to detection, yet its gravitational fingerprint is everywhere. Roughly 27% of the universe is made of it. For every atom of ordinary matter, there are 5 of this hidden kind. We can't touch it, but we can see its influence. In the shapes of galaxies, the clustering of cosmic structures, and the bending of light through gravitational lensing. Imagine invisible rivers flowing through the cosmos, threading galaxies together in filaments that stretch across billions of light years. These rivers are made not of stars or dust, but of dark matter, the scaffolding upon which the visible universe hangs. When we look at the largest structures of the cosmos, the cosmic web, what we see is merely the glowing residue of a deeper architecture. Galaxies form where dark matter clumps, as though drawn to the invisible bones of creation. And yet, we have no idea what dark matter actually is. It could be made of undiscovered particles, WIMPs, axions, sterile neutrinos, or something stranger still. Or perhaps it's not matter at all, but a manifestation of gravity behaving differently on cosmic scales. Decades of experiments have searched for direct detection. Deep underground, in frozen caverns, shielded from the noise of the ordinary world. But so far, not a single particle has revealed itself. The most elusive ingredient in the universe hides in plain sight, surrounding us, passing through us every second, indifferent to our instruments. Still, we know it must be there. Without it, galaxies wouldn't exist. The stars we see are not massive enough to hold themselves together. It is dark matter that provides the invisible glue, the gravitational binding that gives structure to the cosmos. It doesn't interact with light, yet it dictates where light can go. It doesn't shine, but it shapes what does. It is the shadow that defines the form. There's a poetic irony in this. The most abundant substance in the universe refuses to be seen. It doesn't reveal itself in brightness or radiation, but through the quiet precision of its pull. It is a force that rules through silence, a whisper powerful enough to sculpt galaxies. Perhaps it is a reminder that not all strength announces itself, that some powers exist only in stillness. But even as dark matter holds the universe together, another mystery threatens to tear it apart. Dark energy. If dark matter is the hand that grips, dark energy is the breath that pushes away. In 1998, astronomers studying distant supernovae made a discovery that upended cosmology. The expansion of the universe isn't slowing down as gravity should dictate. It's speeding up. Something is accelerating space itself. This invisible energy accounts for nearly 70% of all existence. We don't know where it comes from or what it truly is. It acts not within space, but upon space, stretching it, driving galaxies apart faster and faster. Every second, the universe grows larger, not because galaxies move through space, but because space itself expands between them. Like ink dots on an inflating balloon, the galaxies drift apart not by motion, but by creation. New space emerges out of nothing, and with it, time itself flows forward. Dark energy may be the simplest idea in physics and the most baffling. The leading explanation is that it's a property of space, a cosmological constant, an energy intrinsic to the vacuum. In quantum theory, even empty space seethes with activity. Virtual particles popping in and out of existence, creating a froth of energy that never fully cancels. Perhaps this vacuum energy, magnified across cosmic scales, fuels the expansion. Yet when physicists try to calculate its magnitude, the result is off by a factor of 10 to the power of 120. The largest discrepancy between theory and observation in all of science. It's as if the universe laughs at our numbers. Some think dark energy may not be constant at all. It could evolve, shifting over time, growing stronger as the cosmos ages. Others suspect we're misinterpreting the clues, that what we call dark energy might be the effect of something even deeper, perhaps the geometry of higher dimensions leaking into our universe. There are theories where the cosmos we see is only one bubble among countless others, each expanding with its own tempo, each governed by its own balance of forces. Ours just happens to be one that grows ever faster. A universe fated not for collapse, but for isolation. Because if dark energy continues its relentless acceleration, there will come a day when even light can no longer bridge the gaps between galaxies. The night sky will grow empty. The cosmic web will dissolve. Every island of stars will drift beyond every other, until each galaxy becomes a solitary ember, floating in infinite darkness. Billions of years from now, future beings, if any remain, may look up and see nothing at all. Their universe will seem small, quiet, and still. They will never know that once everything was connected. This is the cruel poetry of dark energy. It is creation through separation. It builds by tearing apart. It expands reality, but in doing so, erases the possibility of connection. What began as a single blazing point of unity now drifts toward eternal solitude. The universe may not end in fire or collapse, but in loneliness, a quiet, infinite dispersal. And yet, there's something hauntingly beautiful in this cosmic melancholy. The same dark engine that will one day dissolve the stars also made them possible. Without dark matter, galaxies would never have formed. Without dark energy, the universe might have collapsed before consciousness arose. The balance between the two, one binding, one breaking, created a cosmos poised perfectly between chaos and order. Existence, it seems, thrives not in stability, but in tension. We stand within that tension. Every breath, every thought, every act of curiosity occurs in the narrow pause between collapse and expansion. We owe our existence to a cosmic conflict we can neither see nor control. Perhaps that is why mystery itself feels sacred, because it mirrors the very structure of the universe. What we cannot understand is precisely what allows us to exist. Even now, astronomers and physicists search for signs of these hidden forces. They build detectors buried beneath mountains, orbit telescopes beyond Earth's glow, and map the gravitational lensing of galaxies to trace the invisible web. Each new discovery deepens the puzzle. The more we learn, the less the universe seems to be made of anything familiar. Maybe that's the real revelation, that what we call matter is the exception, not the rule. Reality might be mostly emptiness animated by unseen energy, with visible matter merely the residue of something much vaster. In this view, we are ghosts clinging to the surface of an unseen ocean, mistaking the foam for the sea. And if dark matter and dark energy are not truly forces but expressions of something deeper, perhaps intention, then the universe begins to look less like a machine and more like a thought. For what else can act everywhere, unseen, yet with such precision and purpose? What else can move everything without touching anything? Maybe these dark forces are the closest thing we have to evidence that existence has direction. Not randomness, but will. But direction toward what? Toward expansion, complexity, awareness, or toward stillness, entropy, and silence? The answer depends on where we stand in the timeline of everything. Right now, in this brief window of cosmic history, we exist between two infinities, the dense fire of the beginning and the cold dispersal of the end. And though we cannot see the forces that guide it, we feel their echo in the spaces between things. Dark matter holds the galaxies together. Dark energy pulls them apart. Between those two invisible hands, everything we know, stars, planets, consciousness, flickers for a moment, like foam between the tides. Perhaps the most powerful force in existence is not light or gravity or fusion, but the hidden equilibrium that allows all of them to coexist. The universe is not sustained by certainty, but by balance, an invisible still point between expansion and collapse, being and non-being. And maybe that is the final lesson of the dark. What we cannot see is not our enemy, it is our foundation. The universe hides its greatest powers not in brilliance, but in shadow. We search for the visible, but meaning lives in the unseen, in the dark rivers beneath galaxies, in the breath of space stretching between the stars, in the silence that holds everything together. In the end, the cosmos may not be driven by a single force at all, but by the tension between opposites, the gravity that binds, and the energy that breaks. The visible is only the echo. The true engine of existence moves beneath, unseen, eternal, and endlessly patient, the hidden heart of reality. The universe gave birth to something that can now observe it. Could that be the most powerful act of all? For billions of years, creation unfolded in silence. Stars were born and died without witness. Galaxies collided in blind majesty. Black holes devoured light without remorse. Yet somewhere, on the edge of one small spiral galaxy, atoms that once burned inside stars began to think. They began to question. They began to ask why. In that instant, the universe stopped merely existing. It noticed itself. Consciousness, the most mysterious phenomenon in existence, and perhaps the only one that gives existence meaning. From the perspective of physics, it is just matter and energy arranged in complex ways. Yet from within, it feels like something. It experiences, dreams, remembers. It loves, it fears, it wonders, and no equation in the universe can explain why. The journey from chaos to consciousness is the most improbable story ever told. Out of hydrogen and helium, gravity built stars. Stars forged heavier elements through nuclear fusion. Those elements formed planets, oceans, and molecules. Molecules formed cells. Cells learned to replicate, adapt, and evolve. And somewhere along that chain of becoming, the laws of physics gave rise to something that could ask about the laws themselves. The universe, through life, turned inward and began to see. In the brain, around 86 billion neurons fire in intricate patterns, each one connected to thousands of others. Together they create an orchestra of electric symphonies, a dance of energy so complex that it produces not just behavior, but experience. When you see a star, the light that traveled for eons strikes your retina, triggers a cascade of signals, and in milliseconds becomes awe. How can electrochemical reactions create the feeling of wonder? How does matter dream? Neuroscience has mapped much of the brain's machinery. The cortex, where sensory data integrates, the limbic system that gives emotion its heat, the thalamus that filters perception. Yet the mystery remains. How does activity become awareness? This is the hard problem of consciousness, the gap between physical process and subjective experience. Science can measure the brain's patterns, but not the spark that lights them from within. Some theories suggest that consciousness emerges when information is integrated in a certain way, that awareness is the unified sum of all experience, the brain weaving countless signals into one coherent narrative. Others, like the global workspace theory, imagine consciousness as a theater. Neurons compete for attention, and whatever wins the spotlight becomes our experience of the present moment. But even these models describe how thoughts are organized, not why they feel alive. There are deeper questions still. Why should matter be capable of experience at all? Why should neurons feel anything instead of merely functioning like switches? Some thinkers, both ancient and modern, suggest that consciousness might not emerge from matter, but that matter itself might emerge from consciousness. This idea, known as panpsychism, proposes that awareness is not something the universe developed, but something it always had, an intrinsic property of existence, like mass or charge. Every particle, every atom, carries a glimmer of experience, however faint. In complex systems like the human brain, those flickers unite into the flame of self-awareness. To many scientists, this idea feels poetic but untestable. Yet it solves one haunting problem. How does dead matter suddenly give rise to life? If consciousness is woven into the fabric of reality, then evolution did not invent it. It revealed it. The cosmos has been feeling in some quiet way since the beginning. Through us, it simply learned how to articulate that feeling. Quantum physics adds another layer of mystery. At the smallest scales, particles behave as probabilities. waves of potential that only take definite form when observed. The famous double-slit experiment shows this vividly. Light acts like a wave when unobserved, spreading out in interference patterns, but collapses into discrete particles the moment it's measured. This raises an unsettling question. What qualifies as an observer? Is it the measuring device, the human mind interpreting the result, or something deeper? An act of awareness itself collapsing possibility into reality? Some interpretations, like the Copenhagen view, suggest that observation is what makes reality real. Others, like the many worlds theory, claim that all possibilities exist simultaneously, and observation merely selects the branch we experience. But whatever the truth, consciousness seems to stand at the threshold between potential and manifestation. The universe exists in a haze of uncertainty until something looks at it. Could it be that awareness itself is a cosmic force, one that shapes what it perceives? In a sense, consciousness might be the universe's fifth fundamental interaction, not pushing or pulling matter, but revealing it. Unlike gravity or electromagnetism, it does not act across space. It creates the space where meaning happens. Think of it this way. Every experience you have, every sound, every thought, every breath, is a union of physical and mental realities. The photons that hit your eyes, the neurons that respond, the awareness that interprets them, all form one continuous process. The division between out there and in here is an illusion of scale. The universe is observing itself through countless windows, each one briefly opening and closing. You are one of those windows. When we reflect on the stars, the light entering our eyes may be billions of years old. That light began its journey before Earth even existed. Yet in perceiving it, we complete its story. A photon that left a dying star finds its final purpose not when it reaches a telescope, but when it becomes awe within a human mind. Consciousness is how the universe finishes its own sentences. And if awareness completes the universe, then meaning itself becomes a form of energy. Subtle, unmeasurable, but transformative. Every thought rearranges the brain's chemistry. Every emotion changes the body's electromagnetic field. Every decision reshapes the trajectory of reality in microscopic ways. We think we are small, but our capacity to think may be the grandest expression of the cosmos. Consider this. The same physical laws that govern galaxies also govern the firing of neurons. Gravity, electromagnetism, nuclear interactions, all of them work together to maintain the electrical potential that makes thought possible. The universe that created stars also created the conditions for introspection. From one perspective, consciousness is just another emergent property of physics. From another, it is the point of the entire cosmic narrative, the moment the universe becomes aware of itself. In quantum theory, measurement determines reality. In life, attention determines experience. What you focus on becomes your world. This strange mirroring between physics and psychology may not be coincidence. The mind, like the cosmos, seems governed by the same principle. Energy flows where observation goes. Throughout human history, thinkers have sensed this connection. Ancient mystics called it the divine spark, the Atman, the observer behind all form. Philosophers called it the soul. Today we call it consciousness. Science describes its mechanism. Philosophy explores its meaning. But neither can escape the paradox. Without consciousness, the universe might as well not exist, because there would be no one to know it does. Some physicists have even proposed that the universe itself might be a vast quantum system whose state is defined by observation, and that consciousness, far from being a byproduct, is the mechanism by which the cosmos evolves. Each act of perception collapses possibility, driving reality forward. Awareness becomes not just a witness, but a participant in creation. And if that's true, then every moment of awareness is sacred. Every thought, however fleeting, is part of the universe's ongoing act of becoming. The stars gave rise to us, and through our minds they continue their creation. The same fire that burns in the cores of suns burns in the synapses of thought. Neurons flash like constellations, electric galaxies inside your skull. The brain is a cosmos within a cosmos, bound by the same laws, powered by the same light. What, then, is consciousness? A byproduct of complexity? A field beyond physics? Or something that transcends both? Perhaps it is not a thing at all, but a relationship, the meeting point between existence and awareness. Just as gravity is not a force pulling masses, but the curvature that arises between them, consciousness might be the curvature between being and knowing. It is the tension where reality meets reflection. There is a growing idea in science called integrated information theory, which attempts to measure consciousness in terms of information. The more integrated and differentiated a system is, the more consciousness it possesses. A human brain, infinitely interwoven, generates a vast web of awareness. A simple cell less so. Yet even a cell responds, adapts, feels in a rudimentary way. Perhaps awareness scales, not as a binary switch, but as a spectrum, from the faint hum of atoms to the symphony of thought. If this is true, then consciousness did not appear suddenly. It evolved, from single molecules sensing their environment, to animals dreaming, to humans pondering infinity. Each step is the universe expanding inward. Just as galaxies spread through space, awareness spreads through complexity. We are not the pinnacle of this journey, only a moment within it. The implications are staggering. If the universe is conscious, or even semi-conscious, then everything, every atom, every photon, participates in experience. The cosmos is not a stage, but a mind. And death, then, is not the end of consciousness, but a change in perspective. Awareness returning to its wider field. In that view, individuality is temporary, but awareness eternal. This is not mysticism masquerading as science. It is the recognition that the boundary between physics and philosophy may itself be artificial. We separate matter from mind only because we see from one side of the mirror. But the reflection is seamless. Matter becomes mind as naturally as hydrogen becomes light. And yet, for all its wonder, consciousness remains the one phenomenon science cannot fully measure. We can describe its correlates, predict its behavior, even manipulate its contents. But the feeling of being, the taste of awareness, eludes capture. It is the ultimate subjective force, invisible, unquantifiable, yet undeniably real. Maybe that is its power. Unlike the other forces, consciousness does not act on reality. It interprets it. It gives weight to experience. It makes a universe of equations into a story. Without it, time is meaningless, space is empty, and energy is motion without purpose. With it, the universe becomes poetry, a living narrative of observation and memory. So perhaps the most powerful force in existence is not gravity or light, Not dark matter or nuclear fire, but the simple act of awareness, the universe's own reflection looking back. Through us, existence has found a way to know itself. Every question we ask, every wonder we feel, every truth we glimpse adds another layer to that cosmic self-awareness. And in that sense, meaning itself may be the final energy, intangible, immeasurable, but the one that moves us to create, to explore, to continue the story. Because to be conscious is not just to exist, it is to participate in existence. The universe gave birth to something that can now understand it, and perhaps, in doing so, it discovered what power truly means. What if the most powerful force in existence is the will to exist? The universe, by every law we know, should be fading. Entropy, the great dissolver, pushes all things toward disorder. Stars exhaust their fuel, atoms decay, galaxies drift apart. The second law of thermodynamics is merciless. Energy spreads, heat cools, patterns collapse. And yet, in defiance of this cosmic drift toward chaos, something extraordinary keeps happening. Out of dust, order rises. Out of silence, music forms. Out of void, meaning speaks. This is not the story of destruction. It is the story of resistance, of the universe's quiet refusal to surrender to nothingness. Every galaxy, every life, every thought is a rebellion against entropy. The stars that burn are temporary, but their light creates the possibility of more. Even decay, in its own way, seeds new beginnings. In the ashes of a supernova, elements are forged. In the collapse of a star, new worlds are born. The universe does not die easily. Even in death, it creates. Physics tells us that entropy must always increase, that the total disorder of the universe grows with time. And yet, within that rule, something remarkable occurs. Local pockets of order appear, like eddies in a vast river. Stars condense from clouds. Planets cool into stability. Molecules align into self-replicating patterns. Life blossoms. Awareness emerges. Somehow, the cosmos finds ways to organize itself into greater complexity, even as the grand sum moves toward decay. It's as if existence contains within it a hidden tendency not merely to survive, but to evolve. The great thermodynamicist Erwin Schrödinger once asked, "How does life persist in a universe ruled by entropy?" His answer was that living things feed on negentropy, order borrowed from the environment. A plant takes sunlight, a flame from a star, and uses it to build structure. A mind takes information from chaos and turns it into thought. The universe allows temporary islands of order, small havens in the tide of disorder. But those islands are not mistakes. They are the very mechanism by which existence continues. Look closer, and a pattern emerges, a rhythm written into reality itself. The interplay between chaos and order, between decay and creation, is not conflict, but collaboration. Entropy breaks down the old, scattering its fragments so that new structures can form. Every act of creation begins in destruction. The death of stars makes life possible. The collapse of form gives rise to imagination. The universe, it seems, builds by undoing and learns by forgetting. What drives this cycle? Not any of the four known forces, nor even the dark ones that govern the cosmos from behind the veil. It is something subtler, a principle of becoming, an impulse toward self-organization. From the smallest quantum fluctuations to the largest galactic webs, systems naturally evolve toward patterns of coherence. They form feedback loops, balance opposing energies, and generate complexity from simplicity. Physicists call this emergence, the appearance of new properties that cannot be predicted from their parts. Hydrogen atoms alone cannot predict the existence of a star. Amino acids alone cannot predict the spark of consciousness. Yet when enough pieces connect, something greater arises, a whole that transcends its sum. The universe seems to know this dance by heart. It builds structures that can observe, replicate, and remember. From that memory comes identity. From identity comes curiosity. And from curiosity, creation. Perhaps the most mysterious energy in the universe is not kinetic or potential, but intentional. Something compels matter to organize, energy to flow, life to persist. Even the laws of physics themselves, those unbreakable symmetries, are expressions of order in defiance of chaos. Why should the universe obey rules at all? Why should it favor structure, coherence, and pattern? Maybe the most powerful force in existence isn't one we can quantify, but the drive toward meaning, the urge to exist, to connect, to know. Consider the human story. Every civilization, every poem, every scientific breakthrough is an echo of that same impulse. We are not separate from the universe. We are its continuation. The curiosity that led atoms to arrange into neurons is the same curiosity that leads neurons to ask about atoms. When we look at the stars, we are the cosmos asking itself how it began. When we build telescopes, we extend the universe's own senses. When we dream, we extend its imagination. And perhaps that's the secret hiding beneath all power: persistence. Gravity wins through patience. Life endures through adaptation. Consciousness thrives through wonder. Even entropy, the supposed destroyer, becomes the stage upon which order performs its eternal improvisation. Destruction and creation are not opposites, but partners in a single act of becoming. The universe is not a war between forces. It is a conversation between them. If we strip away every particle, every field, every dimension, what remains is the principle of transformation, the tendency of energy to evolve, to take on new forms, to explore its own possibilities. It may not have a will in the human sense, but it has direction, rhythm, intent. The Big Bang was not merely an explosion. It was the beginning of a question. What can existence become? And for billions of years, the universe has been answering itself in light, in form, in thought. Even the void participates. Quantum fluctuations, tiny bursts of energy in empty space, constantly create and annihilate particles. The vacuum is not stillness, but a restless field of potential. Out of what seems like nothing, something always emerges. The universe cannot stay quiet. Even silence births sound. Even darkness breeds light. This is the paradox at the heart of reality. The universe is moving toward disorder, yet becomes more intricate along the way. Entropy increases, but so does complexity. Every collapse becomes the seed of a new structure. Every ending plants the next beginning. From stars to cells to consciousness, the cosmos continually reinvents itself, as though its truest instinct is to keep becoming more aware. Could that be the ultimate force? Not gravity or electromagnetism, not nuclear or dark energy, but the universal impulse toward connection, the desire to turn chaos into pattern, energy into story, matter into mind. This isn't mysticism. It's what physics shows us. Systems far from equilibrium, storms, galaxies, living organisms, do not freeze into entropy. They use the flow of energy to self-organize, to build bridges across the abyss of decay. Order emerges not in spite of entropy, but because of it. Think of it. Entropy births stars. Collapse births life. Dust becomes memory. The dead fuel the living, and the living prepare the ground for what comes next. The cycle is endless. The will to exist is not separate from the law of decay. It is the law of decay understood deeply enough to see that endings are beginnings in disguise. In that light, the human spirit, fragile, fleeting, endlessly curious, is the universe's most improbable triumph. Against all odds, we persist. We build civilizations, knowing they will fall. We write music, knowing it will fade. We love, knowing it will end. And yet, through those acts, something eternal emerges. Meaning. Perhaps meaning itself is the universe's fifth state of matter, intangible, invisible, but the only one that resists entropy. Meaning is what turns entropy into story, energy into emotion, and existence into experience. It binds the physical and the conscious, the measurable and the miraculous. It is the thread that connects the smallest quantum vibration to the vastest galactic spiral, and the heartbeat in between. So when we ask what the most powerful force in existence is, maybe the answer isn't a force at all. Maybe it's a tendency, a drive, a cosmic yearning written into every atom and echoed in every soul. The will to continue, to rise from decay, to turn emptiness into expression. The universe doesn't fight entropy, it dances with it. The darkness doesn't erase the light, it gives it contrast. The void doesn't destroy creation, it gives it purpose. Even now, as the cosmos expands toward its distant silence, new stars are being born, new worlds are forming. Somewhere, consciousness is awakening for the first time. The story goes on, carried forward by the same invisible momentum that has moved since the beginning, the will to exist. Perhaps that is the power beyond power, the quiet insistence of the universe to keep creating, even as it falls apart. The fire that never truly goes out, only changes form. The persistence of connection, meaning, and awareness. Life as the echo of a cosmic vow. I will not end. And if that is true, then the universe is not a tragedy of decay, but a song of becoming. Every collapse is a note in that song, every spark a verse. And through it all, one force endures, not the strongest, not the brightest, but the most faithful, the will to continue. Perhaps the greatest force isn't out there. It's the one asking the question. When the stars fade, when gravity loosens its grip, when even light surrenders to the slow unraveling of time, one thing still moves through the dark, the act of understanding. Long after the fires of the cosmos cool to embers, the echo of awareness endures, not as matter, not as energy, but as meaning. Every force we've named, every equation we've written, every story we've told, was the universe's way of learning what it is. In the end, gravity will fall silent. The strong and weak forces will fade as particles decay into simplicity. Electromagnetism will have nothing left to illuminate. Dark energy will continue its cold expansion, stretching existence thin until all distances lose significance. The cosmos will reach equilibrium, perfect, motionless, and lifeless. And yet, even then, the question will remain, suspended like a note that refuses to fade. Why was there something instead of nothing? That question is not human. It is cosmic. It has been echoing since the first instant of creation, when the universe split from symmetry and became aware of difference. When it began to ask, in its own language of light and time, "What am I?" Every star, every atom, every mind since then has been part of that ongoing reply. We are not separate from that question. We are its continuation. When you look up at the night sky, the photons entering your eyes are older than the earth beneath your feet. They have traveled across billions of years just to collide with your awareness, completing a story that began before you were born. In that moment of recognition, when the cosmos sees itself through you, the universe's oldest force awakens once more. Understanding. The quiet current running beneath every law, every motion, every force. It does not pull or push. It connects. It does not conquer. It contemplates. It began as gravity shaping form, as fusion igniting stars, as chemistry building life. And now it becomes reflection. The universe finally turning its gaze inward. Perhaps this has always been the point. The cosmos is not a cold mechanism, but an unfolding awareness. From simplicity to complexity, from particle to person, it has been climbing toward consciousness, toward the ability to know. And once it knew, it began to wonder. The first mind that looked upon the stars was the moment the universe realized it was alive. That realization was not the end of the story. It was the beginning of meaning. For even as everything moves toward dissolution, awareness continues to weave significance from the fabric of impermanence. We study the laws of nature not to control them, but to remember that we are part of them. Every act of curiosity, from a child gazing at the sky to a physicist chasing the birth of time, is the universe remembering itself. Maybe that is the final paradox. The universe's most powerful force is not physical at all. It cannot be measured in joules or written in equations. It exists in the act of asking, in the spark of curiosity that keeps existence from going dark. That is what has driven the cosmos since its first breath. The desire to become more than it was, to see itself more clearly, to turn chaos into comprehension. And so, when everything else fades, curiosity remains. It is the gravity of awareness, the light of thought, the fusion of wonder and will. It is the eternal question living within every conscious being. What am I? Why am I here? The universe asks these questions through us, not to find an answer, but to keep existing through the act of asking. Look into the night one last time, not to seek, but to recognize. The stars are not distant fires. They are reflections of your own awareness scattered across the infinite. Each one burns with the same light that lives behind your eyes. The galaxies are neurons in a vast cosmic brain, firing across aeons. The universe thinks through you, dreams through you, remembers through you, and perhaps that is what remains when all else is gone. The awareness of awareness itself. The final force, the one that cannot decay because it is not made of anything at all. It is the breath behind every creation, the silence between every note, the presence that endures even when the stars have forgotten their names. The universe began with expansion, with a question flung into the void, and maybe it will end the same way, not with collapse or extinction, but with a whisper of understanding, echoing endlessly into the dark. The universe's most powerful force is not gravity, nor light, nor time. It is the desire to know itself.